Do you want to understand Windows API programming with VBA? If yes, this video and the whole series is definitely something you should watch. Hi, I'm Philip from codekabinett.com, and this is the second episode in my video series about Windows API programming with VBA. And just a quick few words. We're going to talk about strings and the Windows API today, and it might appear as if there are a couple of plot holes in the story and I'm trying to sweep stuff under the carpet. Yes, that is actually true, but not because I want to keep that knowledge from you, but because I try to keep to a 10 to 15 minutes video length here, and there are topics that will be covered in the next video in this series. Okay, with that being said, let's dive right in. So, I already did a little bit of work and prepared a function here where we can use strings with the Windows API. And that is basically the MessageBox function. And yeah, you might say that is not very useful, but let's see. Once again, it's the most simple example I could find, and we will look at another example later probably. So I copied over the declaration from the documentation on the Microsoft website, and there are two types here, LP, C string. Yeah, that is obvious. These are supposed to be strings. And even if the types would have not really indicated that they want to be strings, you probably used a message box before and know that there are two strings, one for the actual text of the message box and another one for the title. And that is exactly what these are. And I already took the liberty to declare this function here. So we start with the function name, which I use locally, and then there is the function name in the API, and we just ignore this A here at the end and just assume, yeah, that is a message box, just as I declare the local function. And then we arrive at this argument here, which we are also going to ignore for now. But here are the things we care about, and I simply declare these two strings as string. And I want to pass a value from my code, which I use here, to the Windows API to display as text and title of the message box. So I declared these values, these strings, by val. That will become more important later, but now it seems pretty obvious. We pass data there, so by value is the correct declaration for the argument. And it's just declared as string, totally straightforward. And then at the end we have this utype as long, and that is just what the buttons argument is in VBA, which is pretty badly named actually with buttons, because it's all the other stuff that the message box, basically the visual appearance of the message box in regards to the icon displayed, to the buttons shown there, and all that stuff. So let's use this function here, and I just type a message box, and this is the MSG text, and here is the title. And for the utype, there is actually a long list of constants defined in the Windows API documentation that I could or should copy over into my application. But luckily, our Visual Basic MessageBox styles are exactly the same as the constants in the Windows API. So I can just use these. So I go to the MessageBox style and say, yeah, that should be the critical icon, and I want a line break first so that you can see what I'm typing here. And I want a yes, no, yeah, VB yes, no, cancel button, and I think that is enough for now. Let's run this. Oh, of course, I made a mistake. I said we want to ignore the first argument here, and I'm not going to talk about that, but nevertheless I need to edit here, and I just supply a 0 for that. Okay, now let's run this. And this is the text, there's the title, we see our critical icon here, and the yes, no, cancel buttons. So this absolutely worked as expected. And it was totally easy. I just typed in my two string literal values directly into the VBA environment, passed them to the API, and it worked right away. Easy peasy, isn't it? So, great. That's it for today. Bye-bye. You're still here? Yeah, okay. That was a joke. Yeah, if we just want to pass strings to the Windows API, it actually is this simple. But most of the times we want to do something else. We want to pass not information from VBA to the API, but we want to get information back from the API, which happens quite often to be strings. And the most popular functions for these, most asked for, are how do I get the username of the current Windows user, or how do I get the computer name of the local computer my VBA code is running on. But for these, you find 10 million examples. So I choose a different function for the demo today. But all these functions, actually most of these functions that retrieve a single string value from the Windows API, they all operate by the same pattern. So we are going to talk about how to get the default printer name today. But this can be, all what we are going to do here can be totally applied to dozens of other Windows API functions, including the get username or get computer name function. So let's get started with this by looking into the documentation, because there are a couple of details I want to point out here. The function is GetDefaultPrinter. It retrieves the name of the default printer. No surprises here. You've probably also seen the declaration here. It is a boolean which is returned from the function, and then we have this, which is also a string, the PSZ buffer, and we've got a LPD word, which is called PCC buffer. That are the two arguments. Now let's quickly look at the declaration. So the buffer is a pointer that receives a null terminated character string that is interesting, containing the default printer name. If this parameter is null, the function fails and the variable pointed to by PCCH_buffer returns the required buffer size in characters. That is an important information. Now, for the other argument, that is actually the PCCH buffer, and on input specifies the size in characters of the buffer, on output receives the size in characters of the printer name, including the null character. That is always something you need to look out for, including the null character. So, great. Now we can leave the browser and go back to the VBA environment. With this information, let's look at what I have done here. I declared the function name, and once again, let's just ignore the A here. That is not important, but let's look at the declaration of our arguments. The first one is the PSZ_buffer as string, and now we want to pass a string to the Windows API, and the Windows API is supposed to write something into our string. That was the reason why I thought it would be a good idea to use a by ref declaration. Because that's what we usually do. If we have a VBA procedure and we want to pass an argument to the procedure and want to get a value back from the procedure, then we pass the argument by ref. Sounds plausible, doesn't it? Now, the next thing is also by ref the buffer thingy, which is a long because it's a D word, and it's also passed by ref to the API because, as we just read, the API will write to this buffer and tell us how many characters we need to store our string. Now, seems plausible, doesn't it? Great. So now I already prepared a little function here that we can use, and I already got a couple of variables here. So we can get started right away. I think the variable names here, API return value, buffer size, and printer name buffer, they are pretty straightforward. So we need to initialize our buffer. That is something important. We can use the string function to kind of just fill up our buffer to really reserve the memory of that string. And we can use the VB nullchar as character, but how big must our buffer be? And usually, for most of these API functions, there is something in the documentation that says, yeah, this buffer can be up to 256 characters. That's pretty common for Windows usernames, for computer names and stuff. And the name for a printer was originally defined as a maximum of 31 characters. But that is definitely outdated, and I couldn't find any information how big our buffer must be. So if that would still be, we just assume for a moment that is still correct, and I don't even bother to declare a constant for that because it's not correct, but just let's pretend. So we fill our printer name buffer with null chars. That's just random information, but we must make sure our string is big enough to receive the data that the Windows API is going to write to that string, because the Windows API does handle strings a little bit differently, and the string needs to be big enough to store all information that we need for our function here. So, and now we can actually start to call the function. So, our API return value is the return value of GetDefaultPrinter. Now I pass in the printer name buffer here and the buffer size. And if you remember from the documentation, the buffer size is supposed to contain the size of our buffer. We need to tell the API, hey, we allocated a buffer, this string for you, and you can put in 31 characters in there. So we should initialize it to 31 characters, and actually, maybe I wasn't clear on that. It were 31 characters plus the terminating null character. So the buffer size is actually 32. And it would have been fine, but we should use the buffer size also here. And finally, we should assign the return value. So get default printer name. Oh, please pay attention, I didn't mention it. This is just named, the API function is named GetDefaultPrinter, and my local function here is GetDefaultPrinter name. So they are different, but it's hard to miss that on first glance. So our printer name buffer contains the value of the printer name, but it might be shorter than our string actually, because we filled up the buffer to the maximum length. So if the printer name is actually shorter, then we need to trim the excess space. So we should say we want only the left part of the string in buffer size -1 characters. And the -1 because we also want to get rid of that null terminator. So I should save here. That is always very, very highly recommended when working with the Windows API. And now we can try to call our function. So get default printer name. And let's run this. And nothing appears to happen except that access vanished. Oh, I'm slightly disappointed. I don't know why. I really expected a really bad error message before access disappeared. But yeah, well, it's gone anyway. So there obviously is something wrong here, and I deliberately made an error here because it is something that is counterintuitive. I made this error 1,000 times, and it's very likely that you also will make the error, so I thought the best learning experience here is to really show things falling apart. Now, the problem here, that crashed our that crashed our VBA environment is this one. Even though it's perfectly logical, it is wrong to pass in the string by ref. And for now, just memorize this. Strings must always be passed by val to the VBA environment. And you have to watch the next video in the episode to understand why, to as best as I can explain, because it's undocumented and not really clear, but the fact remains we need to pass strings by val to the API. So I just changed this and nothing else. So let's try this once again. And let's see what happens now. Oh, that is much better. PDF24 is actually my default printer. So this function works. But there is one thing we need to address. And that is the problem of the buffer size. Oh, I should rather underline that in red because it's actually a real problem. Originally, the maximum length of a printer name was 31 characters, but it is no more. And it appears there is no defined hard limit. So we cannot know how long the printer name will be. It will probably not be longer than 255 characters or so. So we could just make the buffer bigger and hope for the best that it works. But there is actually a cleaner and better approach to deal with these type of API functions if you do not know how big your string buffer has to be. If you remember, the documentation said, yeah, if you pass in a null pointer for the buffer, or the buffer is too small, the function will fail and the buffer size argument will receive the required number of characters. So what we do now is we call the function, instead of just assigning 32, we call the function knowing that it will fail, and we even remove the actual string buffer and pass in a VB null string to make it absolutely clear to the function, yeah, we don't give you a buffer, we just want to know how big the buffer must be. And we pass in the buffer size, and that is actually correct to pass it to the API by ref. That works as expected, as we will see in a second. And now let's do this again, and let's put in a breakpoint here and let's run this step by step. And now we call the API for the first time. So our return value here is false. That was expected because we did not supply a buffer, so the API could not work. But you see the buffer size has now the value 6, which was not assigned by our code, but by the Windows API. And we've got 5 characters here plus the null terminator. So this was a success, wasn't it? And now let's continue to run the API. And yeah, I should have called it from here, but it still works. And now we don't need to guess how big that buffer must be. The API tells us. Of course, if we no, there is a decent maximum like 255 characters, and we are sure the buffer will be big enough if it's 255 characters. We can just allocate the buffer, kind of initialize our string, pass it to the API, and get back the value. Then we will save one call to the Windows API for getting the buffer length. But there will be some functions where you just can't know how big the buffer must be. And if we're talking about 100, 200 or 300 characters, it doesn't really matter. But sometimes the API needs more storage space, and so it's probably a decent choice to query the API for the required buffer size. Okay, I think we're done here in code. Just one word to wrap things up. Why? Why does the Windows API use this weird pattern of using a function that has a return value and requiring us to create a string to pass into the API, and the API is writing to that string to give us the value back? Why doesn't the Windows API just use the default approach in VBA to have a function that has a return value that is a string and just returns the string to us by doing that way? And the problem is memory management. Now, we have our code inside Visual Basic. The API is in a total different language. It is not running inside of the VBA runtime. So if we want something from the API that needs a decent amount of storage space, like a string, and the strings here are tiny, but a string can be up to 2 gigabytes of memory. That's the maximum length of a string in VBA. So there's something to think about. And now, if the Windows API creates a string for our default printer in this case, or for whatever value we want from the API with a function, then the API must allocate the buffer for the string and pass it back to our program. And then what? We either copy that string or we don't copy it, but the API cannot know. If we immediately copy it, then the Windows API can release the memory that was used for that string, and the memory is free, everything's fine. But when should the API do that? It cannot really know when we copied the string and no longer need the storage memory area that was allocated for our buffer. So this is going to be a huge problem in regards to memory leaks, and you can't really call that a leak because you're kind of tossing out memory out of the window, because it's basically gone once it's used for that, because the Windows API cannot know when is that not required anymore. So the approach must be different here. Which is our VBA code, allocates the memory required for the string data. We do that. And then we tell the Windows API, okay, here is the buffer, and put in your information in that buffer, and we get the data in our buffer. And then only we are responsible for freeing up that memory. If our VBA procedure finishes and the string goes out of scope, the VBA runtime will say, yeah, we don't need that anymore, and will clear the memory and release it back. So that is an easy way to handle the memory. But that is the reason why so many Windows API functions are built that way, that we in our VBA code allocate the memory that is required for the information we want to get from the Windows API. Okay, yeah, I totally busted my 10 to 15 minute limit here. I'm sorry about that. I hope you liked the video nonetheless, and I would really appreciate it if you would put in a thumbs up down there, and maybe you want to subscribe to the channel. And actually you have to subscribe to the channel because you must watch the next episode where I will fill in all the plot holes from today. Thank you for watching. Bye bye.